I guess this is the last note for logic. And I will read what I have written. In the arithmetic of numbers, plus, minus, dot, and this division operates on two numbers. Similarly, in logic, and or implies and if and only if connects two statements. Very important, they connect two statements. In A-level marking schemes, sometimes it connects numbers. In arithmetic, plus, minus, dot and division are different operators. Similarly, in logic, and or implies and if and only if are different operators. That is, if P, Q are statements, then P and Q, P or Q, P implies Q, and P if and only if Q have four different meanings in logic. It's very important for you to understand it. Observe that P and Q is true only on one occasion. P and Q is true P and Q is true only on one occasion. P or Q is true only in three occasions. And P implies Q, and P if and only Q, is true on two occasions. Using this show that no two of P and Q, P or Q, P if and only if Q are equivalent. It is not, mathematical thing, but this is one way of justifying that these three are different. Further, observe that P implies Q is false only when P is true and Q is false. When you take P implies Q, this is false when P is true and Q is false. And P or Q is false only when P, Q are false. P or Q is false when both P, Q are false. Hence show that no two of P and Q, P or Q, P implies Q, P if and only if Q are equivalent. You can count and say, it is not a logical thing, but one way of convincing that all of them are different. I am saying then to proceed further, you need to understand and feel the differences among the logical meanings of the logical connectives. And or implies and if and only if. This task cannot be achieved by memorizing the definitions of and or implies and if and only if. Just by memorizing or cramming, you cannot get the feeling. Besides, this cannot be achieved by showing that P and Q, P or Q, P implies Q, and P if and only if Q are not logically equivalent, if P and Q are statements. By proving that, again, you cannot convince yourself. Of course, you must be able to prove, but to get the feeling is a different thing. It is like if somebody wants to know the taste of curd, actually if somebody asks me that, do I know the taste of curd? I say yes, because I guess I ate curd 2-3 days back. If I ask the person, do you know the taste of curd? He will say yes. But nobody knows the taste I get and the taste he gets are the same or not. We don't know. There is no way of checking. You will get the feeling through actual exercises, most probably. You cannot learn to swim just by reading books on swimming without jumping to water. You need to keep in mind the saying, if you want to go to heaven, you must die. That's the only way. I have Mr. Hearing at the end. So, I am going to assume that you know the meaning of all of them, as well as, by the way, I have lied only once in this class. Only once, I think. Because now we have and, or implies if and only if before that. No and for all. For you. For some. These are called quantifiers. This is universal quantifier, this is existential quantifier. And you have in arithmetic plus, minus, dot, actually plus minus same thing, dot and division. Again they are the same thing. I guess by a mistake I said on the previous day mathematics is made of this 5 and this 2. That's not true. Mathematics is made of these 1, 2, 3, 4, 5, 6, 7 things. Arithmetic is made of these things. When I say maths, you know, however, to man in the street, arithmetic is mathematics, not for us. And we in colloquial English or the written English or man in the street, they will say, "Dilisena siyala run away." All that glitters is not gold. No, dilisena siyala run away. So this way there are places. Dilisena siyala. Run. No way. Is this true? True or false? Dilisena siyala run away. All that glitters is not gold. True or false? False, you say? Buddha, you? True. I mean, we see. Since we have been saying it, it must be true, no? Buddha,
False.
why it is false?
The correct statement should be some that glitters is not gold.
Why? This is wrong.
It says everything that glitters is not gold. So even gold is not glittered.
This one says gold is not gold. Gold glitters. Correct statement should be some that glitters is not gold. Not gold. Then there are, I mean, if you read even mathematicians' books, you will see so many of this sort of thing. Statements. They mean something, they write something else. So that's why, I mean, I really didn't teach you logic. I mean, it takes time, but I guess you guys are good idea about logic. But nobody can teach you logic also. You need to kind of feel, no? I mean, everyone says, oh, that glitters is not gold. That's what everybody says. When people write notes, maths notes in maths books, many occasions they make mistakes. I was thinking, because I am teaching after a long time as a result, very interesting points. I have forgotten. Not forgotten because yeah, people make mistakes. Parking lots. If you go to a parking lot, you read what it says. That's wrong. Quite often when people use these quantifiers, they are wrong. They are wrong. So now you need to, I have written a book one book in induction book in Sinhala, I guess. That's incomplete book. In that I have asked them to justify that all that glitters is not gold, is false. And now I wrote some problems. These are, I have 20 problems. Some of them may be very easy. These kind of problems are important to convince yourself that now your brain is becoming logical. So it's not that you are going to do very difficult things. Like in this case, can you see his propositions are very elementary, but he writes it to make sure that the reader will get the feeling of the logic. So I don't know how difficult. I think these are very easy, except for one problem, I think. And let us look at the problems before we start chapter 1. First question says, what I want from you is to try. If it doesn't matter whether you can do it or not. Question number 13 is interesting. I am saying there exists xy belongs to R. We take this R for real numbers such that x minus y is 10 to the minus 133 and x squared minus y squared is 10 to the 133. So this is engineering faculty students or physics people will not agree with this. You know why? The reason is, according to this one, x is approximately equal to y. Right? X minus y is 10 to the minus 133. My gosh, who can write 0 point x minus y is equal to 0.00 0 132 zeros and 1. 132 zeros. engineering faculty students will say x is equal to 1. How on earth you can write 132 zeros on a paper like this? So they will say x is equal to y. Therefore, that is impossible. Here what I am saying is x squared minus y squared as 1 and 133 zeros. So it is impossible for a man in the street to believe it. That is why I wrote it as a question. And another reason for this, but can you see, but when this is how we write approximately equal to I know. So another reason is that we draw the graph of y is equal to x squared like this. So if you look at the graph here, if x and y are very close, x squared and y squared are also very close from the graph. No? I mean, it's not that far. 0.000, 136 zeros and 1 is y is almost there. So, you want to say something?
No.
So, x and y are terribly close.
You should interchange x and y now because x is greater than y now. Because minus y is greater than 0.
Yeah, x minus y is greater than 0.
Then x should be greater than y now on the graph. I mean.
On the graph, okay. I can see what it is. Here x, here y, no? It is redundant for there. What I want to say was, when these two are very close, no matter who draws the graph of y is equal to x squared, they are very close. But I am saying no. According to some Sinhala experts, this is called asankheya. I mean, some people have different opinion, but according to this glossary, Sinhala English is something like that. So, what this says is what? You cannot draw the graph of y equals x squared. Can you see that? What we do is give a wrong impression about y equals graph of y equals x squared. Very wrong impression. According to the graph, if some two numbers are very, very close, their squares are also terribly close. So, I mean, that is, every problem I guess has some reason to write, but anyway, you can do it. If you want me to discuss, I can discuss also. But I want you to read. And again, before I run away, now there are this one. No, this one. I mean, these are 4 different meanings. No? So that is why I wrote question number 18. Question number 18. I say Px is x greater than 2 and x greater than 5. Qx is x greater than 2 or x greater than 5. PQ, R is x greater than 2, implies x greater than 5. Next one is x greater than 2, if and only if x greater than 5. So I want you to find these sets. See whether they are different. See whether they are different. That's why I told you just by a day, by doing exercises or cramming the definition of logical symbols, you cannot learn the meaning. It takes some time for sure to, get to the brain. This cannot be crammed. Okay, so I will close the file. I told you I don't write notes for the first chapter. I like the first chapter a lot. You have
We have
this thing, no?
Yeah.
So what he has done was, what is analysis he is asking. And by the way, analysis is far more beautiful than physics, no? So why you not studying physics? No, I'm serious with that. Biomass is far more. That is why it is regarded as the queen of sciences. Not the king. You are a single student, right?
No, I'm English medium.
Eh?
I'm English medium.
No. Your mother. You are a singular person.
Oh, it's awesome.
You have heard of Kusharajuru in Buddhism?
I think.
Somebody with an ugly nose. Somehow, what I want to say is, even an ugly guy like him with a very ugly nose could be the king. But queen is always beautiful. That's why mathematics is regarded as the queen of sciences. So beautiful. Beautiful, so much. So that's why I talk about beauty of mathematics a lot. So much. Okay, so let's go. He is asking what is analysis. I hope you read the book. Then it's very important for you to read and get some idea. Then I assume that you read the first in 2 paragraphs. Then in the question 1, what is a real number he is asking? Is there a largest real number? After 0, what is the next real number? That is, what is the smallest positive real number? Can you answer that question? Buddha? Smallest positive real number. No, if you cannot, it is okay, but then I want you to speak and say, I cannot. Oh, I don't know. Smallest positive real number. Is there a smallest positive real number? Is there? Since you studied the logic chapter, can you prove that there is no smallest positive real number? So we should spend some time in chapter 1, though it is you are not learning anything, but learning to learn. See whether we can show that there is no T-H-E-R, no smallest positive real number. Can you prove it?
Yes.
You can.
Yeah. By proof by contradiction.
Did you study proof by contradiction? So we can share. No, he has the notes, know what we did.
Yeah.
So you should study them, ask them. You can ask me also. So we have done Even though it is only 6 days, we have done a lot. We have changed our brains somewhat. So that you are going to say, assume, proof.
Yeah. Suppose A belongs to R is the smallest positive number.
A belongs to R is the smallest positive number. Suppose A belongs to R is the smallest positive number.
Since A belongs to R, A over 2 it belongs to R.
Since A belongs to R, we have A over 2 also belongs to R.
Observe that A is greater than A over 2.
Observe that A is greater than 0 over 2, that's also greater than 0. Then
So this is a contradiction since
this contradicts the fact that A is the smallest positive number. This contradicts the fact that because A by 2 is less than A and A by 2 is also positive. So this one, good Buddha, thank you for the proof. There is no smallest positive number. Nothing like that. So that's why I told you, it's very important for you to read this thing. You are not learning geometry from the first chapter, but you are learning, why should you learn geometry? Why should you learn analysis? That's what you are learning from the first one. Anyway, is there a largest real number after 0? What do you think? Is there a largest real number, for instance? Yes or no? Buddha, is there a largest real number? No. Buddha? No. They say no. You want to agree with them? Are you in the same boat?
We consider infinity not to be real.
Infinity is not a real number.
Yeah. So it's no. In the same way we can say 2A is greater than A. If we consider A to be the largest real.
Yeah. So you are going to assume A is the largest real number. Then
2A is larger.
2A is larger than A. How do you know? You said, we are learning geometry. You said, suppose A is the largest real number. Then you are saying 2A is greater than A. I am asking, how come? Why? In order to say so, you have to prove that A is, if you want to say 2A is greater than A, you have to prove that A is, Buddha, we have to prove that A is positive. If A is positive, only 2A greater than A. So it's good that anyway you started, suppose A is the largest real number, then you said 2A greater than A. I asked you why, you couldn't answer. As soon as you assume that A is the largest real number, you have to show that A is positive. Can you prove that A is positive?
Assume.
You assume A is the largest real number. See, the pure mass is like this. We cannot take anything for granted. We have to prove everything. I guess he is going to do physics. And you were not well, that's why you couldn't come. Previous days? Yes?
No, not on in your like previous years, but only on Sunday. I was like not well with there's like an issue that I had to work concerning that issue. So
Anyway, can you prove that largest real number is positive?
it is the largest one, right? So in the real number, like the negative part is always smaller than the positive one. So the term largest means
Puta, can you prove that largest real number is positive? We are going to prove largest real number is positive. Puta?
0 is a real number.
Mm-hmm.
We assume that A is the largest real number. So A must be larger than 0.
Very good. That's the proof. The reason I am asking is when you are going to prove something, you have to write everything. Otherwise, you cannot overlook. That is the thing. This proof is very good. Thank you.
Sir, but I have a problem. So, we said to show that the largest positive number is positive, no? Largest number is positive, no?
Yeah.
So, in order for the largest number to be positive, the largest number needs to exist.
Yes, of
But
course.
the largest number doesn't exist, so. Well,
No. He is assuming A is the largest
okay.
under that assumption. Okay, what is the smallest positive real number? Can you cut a real number into pieces infinitely many times? Can you cut a real number into 2 pieces? I don't understand what that it means. Can you cut a real number into pieces infinitely many times?
I think he is implying dividing.
Dividing what?
So, when you divide a number by 2,
Getting.
yeah.
Okay. Why does a number such as 2 have a square root, while a number such as -2 does not? If there are, I hope now I am reading to show you that you also have to read the same way in order to learn. That's the only way. If there are infinitely many reals and infinitely many reals and infinitely many rationals, how come there are more real numbers than rational numbers? That's a very interesting problem that we are not going to answer today. There are more. I have written a book, Sinhala සංඛ්‍යාව පරිමේය වීමේ සම්භාවිතාව. The probability of a real number being rational. How much the probability will be? It's a small book. I will try to bring it next day to show you. Anyway, let's read it and go. No, otherwise, certain questions is good to answer. How do you take the limit of a sequence of real numbers? So, limit is something we are going to learn rigorously. Which sequences have limits and which ones don't? If you can stop a sequence from escaping to infinity, does this mean that it must eventually settle down and converge? I guess you don't know the meanings, no? Converge, you know the converge mean. In A level you will see here the word converge. Okay. So, can you add infinitely many real numbers together and still get a finite real number? It's a very good question. Can you add infinitely many real numbers together and still get a real number? Finite real number. Can you add infinitely many rational numbers together and end up with a non-rational number? More interesting. So the reason I am reading is you need to read and spend like 5 seconds, 6 seconds. Think about it. You add infinitely many rationals, end up with an irrational number. Can it happen? How come? You may not be able to answer. It is okay. In pure maths, nobody can answer all the questions, otherwise pure maths will collapse. Nobody can answer all of them. Can you okay, if you rearrange the elements of an infinite sum, is the sum still the same? You understand that question? You all need to read this chapter very carefully. Don't try to answer the questions, but you have to see the questions. And you have to see that there is a question. That's very important. He is asking, I have told them when you are away, while you were not in the class. Suppose you have bunch of real numbers, say A1, A2, A3, A4, like this. You add, suppose it converges to 5, for instance. He is asking, suppose you rearrange this thing. I write first one A100, second one is A1, third one A220, A30, A2, like this, some kind of a rearrangement. Will we get the same sum? That's what he is asking. What do you think?
It's an infinite sum, right?
Yes, of course.
Finite sums, so if there's a pattern for infinite sums, then it kind of makes sense how it goes to infinity. Like 1, 2, 3, 4 and go. So it's like 100, 4, 20, 30. You cannot predict what comes next. So the result will also be like kind of unpredictable in that case if we talk about the infinite sum. If the order is shuffled.
Mm-hmm.
But yeah, that's the case. If the sum is like 100, A1 to A100, that's like 100 elements, like 100 numbers that we are adding. That's not infinite, but that's finite, and we know there's only 100 things that we add in, and we are already it up along the line. So it doesn't matter if we shuffle it or not, because it's finite. And when you say finite, the order matters to predict what comes next. Yeah, if it converges into a real number.
For you, I am asking, if I rearrange, will I get the same number for you, or can it be infinity, negative infinity? Always 5? He was saying something important. He said that if you have 100 numbers, A1, A2, A3, plus and so on, plus 100, he was saying that no matter how you shuffle this thing, answer remains the same. He said that. Now the question is, we have infinitely many numbers. Thank you. That line is correct from you. infinitely many numbers, will we get the same thing? What do you think? We may not, or we may. Uttara, you, to this day we don't know, no? That's the good answer. We are going to learn it, that's why he's asking questions. To this day, we cannot answer. Then he is asking, what is a function? What does it mean for a function to be continuous, differentiable, integrable, they are very bounded? Can you add infinitely many functions together? What about, so I should not be doing this thing, but I want to make sure you read like the way I read. Every line is very important. You should be curious. He is trying to drive you crazy. Curiosity. Can you add infinitely many functions together? What about taking limits of sequences of functions? Can you differentiate an infinite series of functions? He is asking. Suppose you have f1 of x plus f2 of x plus f3 of x. No. It goes. And you, for the derivative, you write like this, no? Dash. Have you seen it?
Yes.
For the derivative. I mean, he is asking, is this true? f1 dash x plus f2 dash x plus f3 dash x. Is this true? That's what he is asking. What is your guess? Anyway, I don't need an answer, but he is asking this kind of questions. What about taking limits? Can you differentiate an infinite series of functions? What about integrating? That is again a good question. These questions are replied in my Anante Samaga Hora Dekak, that's a book written in Sinhala. He is asking. He's asking, are they the same? They don't have to be. As I told you in my book, I have answered both questions. A very nice examples I have written. I think you cannot answer them today. I think. They don't have to be the same. There are times that they are the same, but very often they are not the same. Only thing is that in your A-level class, when your teacher writes e to the x is 1 plus x squared over factorial 2 plus x cubed over factorial 3 plus and so on. Now, derivative of e to the x, d by dx, is d by dx of 1 plus x squared over factorial 2 plus x cubed over derivative of that thing is this thing, but maybe your teacher told you derivative of 1 is 0, derivative of x is 1, derivative of x squared over factorial 2. You are taking derivative of each term. But he hasn't proved anything. You didn't ask, sir, why, how come, how do you know? You see what I'm trying to say? Here we have to add first and then differentiate. Here we are differentiating first and then adding. Most of the things in this world don't commute. Commutative. These are not commutative. I even putting socks and shoes. Suppose you put the socks first and then you put the shoe. You put the shoes first and then you see what I'm trying to say? I have written all of them in these two books. If you can find from the Open University. So he is asking these many questions. That's why I told you it is good. Can you differentiate an infinite series? What about integrating? If a function f takes the value 3 when x equals 0 and 5 when x is equal to 1, does it have to take every intermediate value between 3 and 5 when x goes from 0 to 1? He's saying f0 is 3, f1 is 5. So this is a function. At the point 0, 0, there is 1, 1, 2, 3, 4, 5. At the point 0 it is 3. At the point 1 it is 5. Now when you are going from here to here, does it take every value between 3 and 5? That's what he is asking. Can you see? You are going from here to there. At the point 0 it is 3. At the point 1 it is 5. Now you have to go from 0 to 1. Does it take every value between 3 and 5? So you need to think them. So I am it seems that I am thinking because I am reading. You have to read carefully. You may already know how to answer some of these questions from your calculus classes. But most likely, these sorts of issues are only of secondary importance to those courses. This A level, you don't care for this. The emphasis was on getting you to perform computations. To this day, you were interested in computations, final answers, like a computer. But, let me read it first. Such as computing the integral of x sine x squared from x equals 0 to x equals 1. That's a good problem, no? O level. You integrate 0 to 1 x sine x squared dx. I guess by method of substitution, no? You do it.
By parts.
Then?
By parts.
Right?
By parts. Integrating by parts.
No. Integration by substitution. X sine x squared. You integrate x sine x squared by substitution.
First substitute then by parts.
Yeah.
0 to 1 x sine x squared dx. So you substitute u is equal to x squared. Then du is 2x dx. So x dx is 1/2 du. So you get sin x squared is sin u, 1/2 1/2 I put it here du. If x is 0, u is 0, if x
Yeah.
substitution. Anyway, so what I'm trying to say is that's not doing it, but in A level, we are interested in this sort of thing. It doesn't matter whether it exists or not, what matters is we just do it like that e to the x thing. We have to add and differentiate. But what we do is we differentiate and add. They're the same. That's what he is asking. These are very interesting questions. But now that you are comfortable with these objects and already know you to do all the computations, we will go back to the theory and try to really understand what is going on. So, I mean, to this day you are interested in computations only, in which you will end up with the final answer. But now we are not, for instance, in A level, say series, you are given a series, you are interested in whether it is convergent or final answer, what is the sum. So you find partial fractions or something like that and get the answer. But you never paid attention, are there series that you cannot do this thing? So you have got a very wrong impression from A level maths. I mean, for instance, you may be doing you have sigma 1 over n times n plus 1, for instance, this series. You are given this thing and you are asked, does it converge? If it converges, what is the final sum? No? Then you write this somewhere sigma. No, I should not. You see, this is in short, limit n tends to infinity. You say sigma 1 over r times r plus 1, r going 1 to n, and you say limit n tends to infinity. Sigma 1 over r minus 1 over r plus 1, r going 1 to n, and you say limit n tends to infinity. When you put r equals 1 over 1 minus 1 over 2, then 1 over 2 minus 1 over 3, 1 over 3 minus 1 over 4, bingo, 1 over n minus 1 over n plus 1. And these are collapsing. So this is called collapsing sum or telescoping sum. So you get limit n tends to infinity. I am not writing the way you write final answer here. 1 minus 1 over n plus 1. Then you say limit of 1 is 1, it minus 0 and 1. So you say series converges and final answer is 1. And somebody give you this question, you will never get this question in A level. Because you cannot find partial fractions, you cannot find function like fr minus f of r plus 1 is equal to 1 over r squared. You cannot do anything. So you get this sort of very, very easy things in A level. And because you have done many past papers, you practice, then you get the impression series, all the problems are like this, which is not the case at all. Most of the problems. Actually, 1 over n square, this one, if you add it, you will get 5 squared over 6. You ask, what? 5 squared over 6, from where on earth you got it? Then you may wonder. And 1 over sigma 1 over n to the 5, you cannot do anything. Do I know what the answer? No. Then you may wonder, say, you have a PhD, you don't know even this. What is your PhD? Nobody in the world knows the answer to this. Nobody knows. You cannot find Sn for this. I mean, no way you can write this and it's 1 over 1 to the 5 plus 1 over 2 to the 5 plus 1 over 3 to the 5 plus and so on plus. Ooh, 1 over 10 to the 5. You cannot simplify this thing anymore. Nobody knows whether this is rational or irrational to this day. They are that difficult. We do very easy things. Because we do very easy things, what happens is, even easy things get difficult for us. When you are doing, if you do difficult things, easy things will be very easy. All right. So, in my case, now I read first page, I guess, with you. I do analysis. The beauty of analysis, you have to see in your own. Nobody can show you. I mean, he's sort of bringing these sort of examples to make you curious about it. But you have to read the book and see why he is asking this kind of thing. But I want to say something about it.
dx e to the power x
Yeah.
අපි පැටර්න් එකක් දකිනවානේ අපි ඔබ දන්නවා 1 ගෙන් x to the power 0 divided by 0 factorial powers 1 by 1 increase වෙනවා අට factorial එකක් දෙන්න එතකොට අපි differentiate කරනකොට rule එකක් තියෙනවද ඊට පස්සේ ඩිෆරන්ෂියේට් කරන්න. ඒක අපිට වෙන වෙනම අරගෙන පුළුවන් නේ ඩිෆරන්ෂියේට් කරන්න 8 by 1. අපි පැටර්න් එකක් දකිනවා ජෙනරල් ටර්ම් එක කරනවා x to the power n divided by n factorial කියලා.
ඔව්.
ඊට පස්සේ අපිට ඒක ඩිෆරන්ෂියේට් කරා වෙනවානේ x nx n minus 1 factorial and n fact
n minus 1 factorial you get.
Yeah, x to the n minus 1 factor.
Divided by n minus 1 factorial. Yes.
එතකොට අපිට අර කියන්න පුළුවන් මේ power එකක් හැම එකකින් අඩු වෙනවා. යට factorial එකකින් අඩු වෙනවා.
ඔව්.
එතකොට 1 එක කොහොමද ආයි x එකෙන් එනවා. අපිට අර මෙයක් කරන කියන්න බැහැ ආයි ඒක e to the power x එකක් එනවාමයි කියලා. අපිට ෆයිනල් ටර්ම් එක ගැන අදහසකුත් නැහැ. අපිට ෆයිනල් ටර්ම් එක ගැන
The problem is, questions is, first add, differentiate the addition. The question is, can I differentiate first and then add? It's not that you have a pattern and you have nice formulas. It's not the thing. Thing is, I have written here, you add the functions and differentiate. Question is, this is the question. Here, this is the question. Can I differentiate first and then add? Not that here you have very nice patterns, nice formulas, etc. It's not the question here. Here this says first add and then differentiate. But here what we have done is first we have differentiated and then add. This is true because if I ask you to find d by dx, x plus sin x, nobody in the world, listen carefully, nobody in the world add x and sin x first and then differentiate. What they do is they differentiate x first and then differentiate sin x and add. That is true, that can be proved for finite things, finitely many numbers. This can be proved. In other words, d by dx, fx plus dx, we will be proving them sooner or later. d by ds fx plus dgx by dx. This can be shown. But there is nothing like that here. However, the thing is, if you want to find the derivative of x plus sin x, actually what it says is add x and sin x, then differentiate. I don't know anybody in the world who add x and sin x first and then differentiate. What they do is they differentiate x first and x and sin x first and then add. That can be done because it can be proved. Here there is no such theorem. No such theorem. And because you are interested in physics, you know the Boyle's law. What is it? Yeah, physics does not know the Boyle's law.
Boys. Ideal gas. Low. Kita kami katakan ideal gas input. Ideal gas amount number of particles constant.
If you answer this, I ask, state Boyle's law. If you write this thing, you will fail. In Sinhala Boyle's law, I'm not supposed to talk in Sinhala, but to the contrary, I'm going to tell it. Achala Vayu Skandeka. නියතස්නත්වයකදී පරිමාව එහි පීඩනයට ප්‍රතිලෝම සමානුපාතික වේ. If somebody asks you what is Boyle's law, that is it. නියත උෂ්ණත්වයකදී අචල වායු ස්කන්ධයක පරිමාව එහි පීඩනයට ප්‍රතිලෝම සමානුපාතික වේ. You couldn't say Boyle's law, no, I said it. What I am asking is, have you proved it? He's asking you. Do you know that nobody in this universe can prove it? Do you know that? Nobody in this universe can prove Boyle's law. Do you know, Buddha, that nobody can prove it? That you have to, if you are going to do physics, it's good that whatever you think, think about it. Yeah. I mean, don't. Now, in Sri Lanka, in education, what happens is there are tuition classes. School also, teacher tells certain things. We never question the teacher. You go to tuition classes. That guy over there in the tuition class appear like he is the professor of the professors in the world. He talks big. He doesn't know anything, and he does not know that he does not know quite often. He or she, by the way. But in your case, you have to be careful. What is said? Is it true? Why it is true? Is it false? Why is it false? Then only you will get an idea. Many things in physics cannot be proved. I'm not saying they are false. And you need to understand this proof word. The word proof comes in mathematics, not in other subjects. They say verify at the most. I don't know the single term for verify. Done! That's what you get. So you can justify Tahul Quran. You go to the physics lab, get maybe a balloon or something, put some gas, you press it, you tell the students, look at it. I am increasing the pressure, balloon is becoming small, volume is getting smaller. Then you can really measure and show it also. That's not a proof, that is verified. Or rather justified. Verify is the Okay, why do analysis? Let's go. It is a fair question to ask. Why bother? Actually, that is better question. Why bother to do analysis? When it comes to analysis, there is a certain philosophical satisfaction in knowing why things work. But the pragmatic person, you are a pragmatic person, these three are not. Because you are a practical person. There is a certain philosophical satisfaction in knowing why things work, but a pragmatic person may argue that one only needs to know how things work to do real life problems. That is very, very true. Because man in the street, normal average person or practical person or pragmatic person, they want to do things in real life. Who cares whether there is a number, whose square is 2? They don't worry about this sort of thing. The calculus training you receive in introductory classes is certainly adequate for you to begin solving many problems in physics, chemistry, biology, economics, computer science, finance, engineering, or whatever else you end up doing. And you can certainly use things like the chain rule, L'Hopital's rule, or integration by parts without knowing why these rules work. Have you ever heard the chain rule? Is it related to this parliamentary member Rattanangai? he makes chains. So anyway, here chain rule is something in calculus. L'Hopital's rule again, integration by parts without knowing why these rules work. So he's asking, why it's important for us to know why it works. In A-level students, they don't worry. If they want to do chain rule, what is the approval? I'm out of touch now. Chain rule, this is the approval. D, F, D, U by dy by du varak du by dx is equal to, you cancel du to du, you get dy by dx. This is A-level chain rule for many. But if you are careful, it is this is a derivative of this function with respect to u. This is a symbol only. There are no fractions. This is again a symbol, no fractions. You cannot cancel anything. This is a difficult theorem to prove, even for me. When I say me, I have to be very careful what I write. But A-level students, they don't. So sometimes we are misled by A-level studies. However, one can get into trouble if one applies rules without knowing where they came from and what the limits of their applicability are. So he says, without knowing the boundaries, if you apply, you are in trouble. That's what he says. Let me give some examples in which several of these familiar rules, if applied blindly, without knowledge of the underlying analysis, can lead to disaster. So he has many examples. These are very important. You need to go through all of them. I will also try to go with you some of them. So that will answer why you should study analysis. That's that one answer, because that is fun actually, quite a lot of fun. I know none of you have seen my book books බිඳුවේ සිට අනන්තය දක්වා විදක් no. අනන්තය සමග හෝරා දෙකක්.
I
No.
saw the cover of it.
You have seen the cover. සංඛ්‍යාව පරිමේයමී සම්භාවිතාව no. ඊළඟ පදේ you have seen.
I searched it for online to buy it, but you can't.
Anyway, I would like you to have that. This one tuition teacher came to my home.
Something like that.
Yeah. He told me that he will publish 2 books, but thereafter he didn't come. Thereafter he did not come. Let's see, if he comes and publishes it, then you can get the book. It's very important. They are good books, very good books. Okay, so let's go through this division by 0. You know it very well. This is a very familiar one to you. I don't know. The calculation law AC equals BC implies A equals B. Does not work when C is equal to 0. I mean, here you know very well. For instance, the identity 1 times 0 equals 2 times 0 is true. But if one blindly cancels 0, then one obtains 1 equals 2, which is false. In this case, it was obvious that 1 was dividing by 0, but in other cases, it can be more hidden. You cannot divide by 0, no? I mean, that is something you know. So, that is the thing here. Now, next one is an interesting one, divergent series. You have probably seen geometric series such as the infinite sum, 1, 1/2, 1/4, 1/8, 1/16. This is geometric series, no? You have probably seen the following trick to sum this series. If we call the above sum S, then we multiply both sides by 2. If you multiply both sides by 2, then you get 2S plus 2 plus 1 plus 1/2 and so on, then you get 2 plus S. 2S equals 2 plus S. Therefore, S is equal to, when you bring 1S to the other side, and hence S equals 2. So the series sums 2. Is this a correct thing? You have to ask yourself. I am not going to say today. Just for the sake of asking, you think what he did is correct? No, don't do that. Let's go to the next one. However, if you apply the same trick to the series, 1 plus 2 plus 4 plus 8 plus 16, you multiply by 2, then you get 2S equals 2 plus 4 plus 8, and so on. That is equal to S minus 1. I hope you are looking at the book, no? You have the book, no? Then implies S is equal to minus 1. Something absurd. We use the same trick that we did in the first one. You got S equals minus 1. You added positive numbers. Sum is minus 1. So definitely we have done some big blunder. It worked in the first one, didn't work in the second one. So you have to ask yourself, so the same reasoning that shows 1 plus 1/2 plus 1/4 and so on equals 2 also gives that 1 plus 2 plus 4 plus equals minus 1. Why is it that we trust the first equation but not the second? Yes.
I think it's because of something like conversion and diversion. Because if we consider it in a geometric way, like a picture, we consider full circle as 1. Half can be considered as this half, then 1/4 as this one, added, and 1/8 as added this portion, 1/16 as added this portion, and we get like real crazy, you know. And after all, at the end we had like one full circle. But adding 2 plus 4 8 means like adding full circles and adding going and on is all full circles, and it's like never ending. So it's I think it doesn't work work on this, like multiplying doesn't work on divergence series, kind of, but only for convergence series patterns.
He says something here. We can do that for convergence series and cannot do for divergence series. That's what he says.
Only looking at these examples only.
A similar example arises with the series S equals 1 minus 1, 1 minus 1 and so on. If you put parentheses according to the way he has put, you get S is equal to 1 minus S and hence S equals 1 half. If you don't understand what I say, you have to ask me, then you get S equals 1 half, no, right? If instead, if you put parentheses, first two terms, second two, and so on, you get 0 plus 0, and hence S equal to 0. Or instead, we can write, if you leave one alone and then begin to put parentheses for each two terms, then you get 1. And hence S equals 1. So you got this. First S equals 1 half, then S equals 0, then S is equal to 1. Which one is correct? So we have to understand, see, when can we, for instance, put parentheses around? We cannot do it. You are getting the impression that we cannot do as we think. The next example, divergent sequences. That we do in maths, whatever we do, there must be a reason. Sometimes people don't like it. When I was doing my PhD, I had a friend from Canada. He was doing comparatorics. Comparatorics is just counting, no? To me, it is. I don't consider it as a decision. However, this guy says in public, oh, person who doesn't do anything worth doing. Because I'm doing analysis here. But this I talk about, you have to study measurable sets functions. So somebody can say it's useless. That is also true. That's how he tells me, but he cannot understand any analysis at all. Yeah. So here is this example 1.2.3 divergent sequences. Here is a slight variation of the previous example. Here say let x be a real number and let L be the limit. He says L is equal to limit n tends to infinity x to the n. Now, if you are doing maths, you cannot write this line. Sometimes say you get the sequence xn. You cannot say let L be the limit of xn. You cannot write. First you have to prove that there is a limit. Yeah, that is the thing. Here he wrote L equals limit. Many people write, especially before, at the very beginning. Then he changed the variables, n is equal to m plus 1. Then he gets L is equal to limit n tends to infinity x to the m plus 1. However, now n is m plus 1 now, then you can write it here m plus 1. Then, however, this is like this, you can see this is limit n plus 1 tends to infinity. This is like x times x to the m. Let me put the dot here as x and they look the same. So, since x has nothing to do with this m, you can pull out x that is true, x, then limit. He says, if m plus 1 going to infinity, then m must go to infinity. So, same thing, m tends to infinity, x to the m. No? The reason is if when m plus 1 tends to infinity, m tends to infinity, and when m tends to infinity, m plus 1 also tends to infinity. Now, he wrote limit of x to the n tends to infinity is this one now. So, if you want, you can write here again m tends to infinity. This variable is dummy, I mean it doesn't play any role. So now what this says is then XL. So we have XL equals L. XL is equal to L. Then what does he say? At this point we conclude that L and and conclude that x equals 1 for arbitrary real number x. So if XL is equal to L, if you divide by L, I mean you don't know whether it is 0 or not, then anyway you get x equals 1. I mean all are wrong. So he is pointing out what usually one does, who is not careful. This is not true. So you have to ask what are the things you did wrong here. Conclude that for an arbitrary real number x. So what he is proving is any real number is equal to 1. That's what he is proving. But since we are already aware of the division by 0 problem, we could be a little smarter and conclude that either x equals 1 or L is equal to 0. That is little bit smart. Because XL equals 1, then you can write, you can take L out. 1 minus x is equal to 0. Then you get L equals 0, x is equal to 1. This is also false, I mean wrong. So what he is saying is you take any x, any real number, you are proving either it is equal to 1 or else its limit x to the n is equal to 0. This is wrong. In particular, we seem to have shown limit n tends to infinity, xn equals 0 for all x not equal to 1. That is not true. But this conclusion is absurd if we apply it to certain values of x. For instance, by specializing to the case x equals 2, we conclude that the sequence 1, 2, 4, 8 converges to 0. And if you put x equals 2, that is x to the n is 2, 4, 8, 16 like that, no? It converges to 0. That is absurd. That's not true at all. And by specializing to the case x equals negative 1, if you put x equals, this is true for any x according to the way it is on the board. If you put x equals negative 1, then you get the sequence minus 1 plus 1 minus 1 plus 1. That converges to 0. That is again absurd. These conclusions appear to be absurd. What is the problem with the above argument? I know what is the problem. It's not that you need to know the answer. What you need to know is you just cannot do anything without saying why it is true. You just cannot do it. Now, for instance, A-level students, if I give him or her a function, he writes 0 to 1 fx dx. But if in order to write that, for instance, if I ask him, who is your wife? What is the name of your wife? He is laughing because he doesn't have a wife. So first I have to ask, are you married? If he says yes, then only I can ask, what's the name of your wife? So we have to make sure that sort of thing. We run into this kind of thing because of that, not being careful. However, if you are not in maths, you think it is just wasting time, talking too many things, or becoming pandit. Like that. That is the thing. Limiting values of functions here. He has another one here. We start with the expression limit extends to infinity sin x. That itself is wrong. That he just wrote sin x, limit extends to infinity sin x. Sin x does not have a limit, you know it very well, no? It goes like up and down always. So he just wrote it. Make the change of variables, x equals y plus y. Then sin y plus y is minus sin y. We obtain limit extends to infinity sin x is equal to limit sin y plus y. Y plus y tends to infinity. Then you get limit minus sin y, y tends to infinity. Minus limit sin y, y tends to infinity. Therefore, you get limit of sin x as x tends to infinity is 0. So this one is saying, before you write limit, actually this is something we are going to learn very seriously. If you are given a sequence xn, we are going to talk it very seriously in the course. When can we write the limit? Many sequences do not have limits, most of them. But what happens in A level, you get sequences which have limits. Then you are going to talk about always, no matter what the sequence you get, the limit. But as long as you are in A level, that is true. But when you are out of A level, that's not true at all. So that's why he is saying, why do analysis? That's his topic. Question mark that is topic now. Anyway, so now we are getting limit of sin x is equal to 0. If we then make the change of variable x equals 5 by 2 plus z, and recall that sin 5 by plus 2 plus z equals cos z, we conclude that limit extends to infinity cos x equals also 0. Then he is pointing out that sin squared x plus cos squared x extends to infinity. Then limits will be 0 squared plus 0 squared adds up to 0. And you know very well sin squared x plus cos squared x is equal to 1. So this is absurd. And thus we have shown that 1 is equal to 0. What is the difficulty here, he is asking? The biggest mistake is just by writing it. Limit extends to infinity sin x. You need to make sure that when you are writing something, that thing must exist in order to write. You just cannot take the limit. If there is no limit, how can I take the limit? So, very important. Interchanging sums. Here he is talking. When you have, I don't want to write it on the board. Here you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So first you add the first column is 6, first row sum is 6, second row sum is 15, third row sum is 24. When you add total the row sums, you get 45. And first sum of the first column is 12, second column is 15, third column is 18, then sum of the column sums is also 45. But this is not true if you have infinitely many rows and columns. Not true. This is the fact that when you have finitely many, this is true. You have double xij, j going on to jm, I going on to n. He is using different suffixes. Yeah. This is true. See, I going on to n. When you have a finite number, that's what happens now. When you have a finite number of rows and columns, you have real numbers here, you have real numbers real numbers, whether you add the rows and total the row sums, then you add the columns, then total the column sums. Answer is the same. You can prove it actually. I guess you said something like that earlier. Not for this. For finite double sums commute. Order is redundant. Order has nothing to do. But when you have infinite here, he has a column here. Can you see this one? Let me write it on the board, otherwise it's not fair. He has this one. 1, 0, 0, all are zeros. Then minus 1, 1 minus 1, 1 minus 1. Again 1 minus 1. So all along this diagonal he has put 1. Below the diagonal minus 1. So when you add the first one, 1 and all these are zeros, so you get 1 here. Second one, 0. Third one, 0. This one, 0. All of them will be 0. If you total the row sums, you get 1. However, if you take the first column sum, 0. Second column sum, 0. Third column sum, 0. If you total all of them. So what is true for finite sums is not true for infinite sums. I told you one example, I asked you to do, no, could not do it yet. Doesn't matter. Sooner or later you will be able to do it. Another thing I forgot to tell you, if you cannot do a math problem, don't get frustrated or don't ask somebody. Try to do it in your own. It doesn't matter. However, you need to practice the habit of thinking the same problem. If you say so, you get a problem and you couldn't do, you ask me, sir, I could not do it. Can you give me the answer? Then you will not learn. If now in the homework said, I told you one problem is difficult. For that problem you can ask me, sir, I couldn't do it. So that is fair, because not everybody can solve every problem. But most of the problems, when you have to try and try, that way you will learn to think how to solve problems. Otherwise, now in Sri Lanka, this tuition business, that is the disaster. Because tuition sir, he actually, this is a good story, more important than the lecture. Once after I came from Sri Lanka, I went to a wedding. So, somewhere in you turn from Tibirigasya before Narayan with the wedding hall, you know, doesn't matter. I was wondering whether you knew it. Anyway, so when I was there, because I was a professor of maths in USA, people didn't want to talk to me. This guy, assuming that this guy is so smart. They don't know that I don't know anything. Maths people don't know anything about that. Physics people, they know the electromotive force, no potential difference, they know, we don't know anything. That is the thing. So nobody, I was alone. I was feeling lonely, my wife couldn't come that day. Then the guy, somebody related to the wedding families, they came and asked me, sir, can I sit next to you? I was sitting on a table, nobody was there. Because they think these guys must be very genius, this and that. That's not true. Then I asked him, I was alone, nobody came and sat with me. Please, be my guest. Then he said, after a while he asked me a question. Question is, he mentioned some name. This girl is one of my batchmates. You you know, sir? I guess no, I don't. You should know, no. His voice went somewhat high. No, I don't. She's exceptionally bright, sir. In your batch. She is your batchmate. You should know, no. You are a bright person. How can you forget about such a bright girl? No. In my batch, there were no bright girls. It cannot be true, sir. I told him, there was a guy in my batch, he is million times brighter than me. Second one is me. Others are under the rim. Whole batch is like that. But in biomass, when it comes to biomass only, I am in the sky, nobody else was close to me. No, sir, it cannot be. Then I asked him, why do you say that you are insisting on me that there was a girl in my batch who was very intelligent, no? Sir, I asked him, no, how do you know? My son goes to her round table tuition class. then how do you know that she is so intelligent? No, sir. He was telling me in Sinhala, but we can talk in Sinhala, it's not good, no? Say, suppose my son has a problem that comes from a previous A-level exam, past A-level exam. When my son says 4 or 5 words, teacher advises the son, Puta, I will tell that problem to you and I will solve the problem also. Can you see? Teacher doesn't allow son to complete the problem. After 4 or 5 words, he knows what this guy is asking. Then I asked, he was telling me, cannot you imagine, sir, how intelligent one should be to guess what my son was going to ask? I told him, these are A-level problems. This girl must have done this thing at least 50 times, 100 times. From the first 4 words or 5 words, he knows this is 99 A-level exam problem. She will, oh, is that right, sir? Well, that's absolutely correct. Otherwise, how can she guess your son's problem? Can you see, people think that tuition people, they play a big game, they act as if they are very intelligent. You think, poor kids, they run into problems. That's the thing. Then he asked me, so you are saying she is not intelligent? I told him I cannot say that she is not intelligent. But when she was in my batch, there was no girl who was capable of doing anything. That's the thing. So tuition people, they pretend something that they are not of. So here, when it is a finite sum, this is true, but when it is an infinite sum, here you have the, let's say the different letter here, ym, yij, I going, j going 1 to infinity, I going 1 to infinity. This does not have to be equal to yij, I going 1 to infinity, j going 1 to infinity. And here is an example. Finite sums, finite double sums commute, infinite double sums do not. That's how I gave you that question. I know you cannot solve it now, but I am not giving you the solution because when we do series, sooner or later you will be able to do it. If you sum up all the rows and then up all the row totals anyway, you get 1, but if you sum up all the columns and add up all the column totals, you get 0. So does this mean that summations for infinite series should not be swapped and that any argument using a swapping should be distrusted? So he is saying there is a, he is saying, always he is saying theorem 8.2.2 for this one. For the other ones also there are some reasons. Again, then integrating, when you have, in A level you don't get double integrals, I guess. Say fxy dx. When we write like this, he doesn't have limits. No? This means first you integrate with respect to x, then you integrate with respect to y. This. So fxy dx dy. This means that, however, what I want to say is that fxy dx dy, this does not have to be equal to fxy dy dx. You cannot interchange the order of integration. Here he has an example. He has e to the minus xy minus xy e to the minus xy. This is a very famous example. So he has used that. You get two different answers. You know a little bit. No, integration is addition. Integral means addition. So infinite double sums do not commute, and integrals, double integrals do not commute as infinite series. So I am not going to go through the details here. So then you will end up with the question, when can we interchange? When can we? There are, of course, situations at which you can interchange the order of integration. So you have to ask yourself, when can we do it? So let's not do that. Then interchanging limits. Let's do that. That's also a simple one. He has this example. X squared over x squared over x squared plus y squared. Limit. First he has y tends to 0, then limit x tends to 0. Other one is limit y tends to 0. Limit x tends to 0, x squared over x squared plus y squared. Since this is easy, let's do it. Double integral example, can you go through it?
Yeah.
You can do it. If you don't understand, ask me. It's important, and as I told you, this is a very famous example. Now let us see, what is the limit of, I will write this way. When y tends to 0, what is the limit of this thing? 1. So you get limit x tends to 0. Actually, when y tends to 0, you get x squared over x squared, and limit x tends to 0, 1. This is 1. Very simple. Here, when x tends to 0, you get limit y tends to 0. If x going to 0, you get 0 over 0 plus y squared. Actually, this is equal to limit y tends to 0. This one is 0. Is equal to 0. So what does this say? You cannot change the order of taking limits. Then you have to ask, when can I do so? In the course, analysis course, you will learn when can you do it. He is just pointing out, that you cannot do it always. That's what he is doing. So, interchanging limits, again he is saying, consider the plausible looking statement. Let me write that also. Limit A has taken extends to 1 minus this limit n tends to x to the n. Other one is limit n tends to limit extends to 1 minus x to the n. The meaning of limit extends to 1 minus is suppose here, for instance, you have a function fx, this is my text, this pen. You gave me a good pen someday, you know. That is something, not Kuta, let's say.
It's a, yeah.
Thank you. Fx, let's say, say 2, x greater than or equal to 1, 0, oh no, not 0, say 1, not 1, 3, x less than 1. So let's draw the graph of this one. Here is 1. If x less than 1, fx is 3. So then 1, 2, 3. So you get an open bowl here. This is the graph. X less than 1, it is 3. When x greater than or equal to 1, it is 2, then here, close bowl. This is the graph of f, right? Then 1 minus limit, here he is saying 1 minus, no? 1 minus means you approach 1 from the left. When you are approaching 1 from the left limit is 3. So in this case, limit of fx, x tends to 1 minus is 3. Limit of fx, x tends to 1 plus would be 2. So here we need the graph of x to the n. Let's draw the graph of x to the n here. Here. X tends to 1 minus. X tends to 1 minus. Here, limit of x to the n as n tends to infinity. Over here, limit of x to the n as x tends to 1 minus. What is the answer here? Equals to limit n tends to infinity. What is the limit of x to the n as x tends to 1 minus? 1. X to the n, x tends to 1 minus. Kuta, what is the answer? You are approaching 1 from left. What would it be? No, I'm asking the answer right away. X to the n. X limit of x to the n as x tends to 1 minus. One x tends to 1 minus. One minus patio means I explained you. You are approaching one from the left. What would it be? A limit of x to the n, x tends to 1 minus. Let's draw some graphs. Draw some graphs. Okay, let's draw. First, I am drawing y equals x. I hope this is a straight line. This is x to the 1. Let's say this is 1. Now I am drawing x to the 2. X square like this way, no? X square. Too straight, cannot draw the next one. See, from here. This is x to the 2. X to the 3. X to the 3 comes here. This is 1. X to the 4 comes here. So then what will be the limit? 1 minus limit. No, let's draw this one separately. Here is 1. 1 here. This is x. Y equals x. X squared is below here. X to the 3 is, that's how you got over there also. X to the 3 is here. X to the 4 is, then what will happen? Limit of x to the n as x tends to 1 minus. Betul? probability is 0. Let's take a number somewhat close to 1 from the left. 7 over 8 is somewhat close to 1, no? 7 over, I'm taking 7 over 8 is less than 1 and from the left of 1. So, first one is x to the 1, 7 over 8. X to the 2, 7 over 8 whole thing square. Next one is 7 over 8 cube. Next one is 7 over 8 to the 4, 7 over 8 to the 5, 7 over 8 to the 6, 7 over 8 to the 7. When n goes to infinity, to which number this 7 over 8 to the n will approach? 0, it comes to 0. So limit will be, if you get the limit function will be, at the point 1 it is always 1. At the point 1 it is always 1, but after that 0. This is limit function, limit. This is x to the n, this is limit x to the n goes to infinity. This is the graph of limit x to the n as n tends to infinity. At the point 1 it is always 1, so limit is 1. But if it is less than 1, I took a number such as 7 over 8 to the n, the bigger the n, closer the 7 over 8 to 0, 7 over 8 to the n. Even if you take 1/2, first one is 1/2, then 1/4, then 1 over 8, then 1 over, like that. All of them go to 0. Now you are learning something from here. All these functions are not broken, continuous, but the limit is broken. That's why I told you, don't ask anybody the answer. Do some pictures and see whether you can come somewhere. Anyway then, this answer x to the n, when x tends to 1 minus is 1 minus will be, now we did it too. This part, x to the n, x tends to 1 minus. This 0, no? This one is 0. Not sure. So here I draw the graph. Limiting graph, x to the n tends to infinity. At the point 1 it is always 1. If it is less than 1, say 7 over 8 to the nth power will go to 0, 1/2 to the nth power go to 0. Each number to the nth power limit goes to 0. Clear or not clear or on the fence?
No, just the whole thing to like the whole both limit functions together it goes to 0. I get it, but I don't get just take
No.
the whole thing together goes to 0. I understand.
No. Let me say, I did a mistake here.
That's the thing.
Because I am not taking n to n goes to
Yeah,
infinity.
that's the thing.
I did not do that. So here I am taking x goes to 1 minus 1. It is 1. So final answer will be 1. I did a mistake. However, here limit of x to the n tends to infinity. Limit of x to the n tends to infinity. What will happen here? N tends to infinity. So this is, I don't know what he has done. This is kind of unfair.
It's a range that
What did you say, sir? I didn't understand.
Yeah.
Okay, that one is correct, no?
Yes.
Oh.
ඒක තමයි හැමෝටම ඉතින් දැක ගමන් ඉන්නේ ඊළඟ එකේ ඉන්ෆිනිටි
0 to 1 ඒක කතාව. හැබැයි 1 ඉඳලා වැඩි වෙනකොට තව කතාවක්.
Very good. Very good. That's why I was going to tell you. Here, if x greater than 1, this limit is infinity. When n tends to infinity, if by any chance x greater than 1, it is infinity. Then x tends to 1 minus infinity is again infinity. However, if x less equals 1, then you get 1. 1 to the n is 1 always. However, if x less than 1, this answer is 0. That's what I was explaining. And then when x tends to 1 minus, you don't have to get the limit. So here, this side you get, somehow I think, I'm wondering whether he has done a mistake here. Sometimes he does mistakes, they are not intentional. And hence, left hand, but we have seen, we also have limitation for all ends, so the right hand side of the limit is 1. That's the meaning that type of. Left.
අර විදිහට පෙප්‍රෝ අර වයිට ප්‍රෝ පසු ඔනේ ඔනේ මාස
So, I mean, although he has written this thing, it is not a fair one, no? Because left hand side is, when you take the limit of x to the n, it tends to infinity. It depends whether it is x equals 1, x greater than 1, x less than 1. 3 answers. Infinity, 1, 0. Then there are constants, no, then there is nothing. By taking limit x tends to 1 minus infinity, or 1 or 0, I mean, no difference. Somehow you just cannot interchange. That's what he wanted to show. Somehow what he has written is this time he cannot be credited, no, this time. You got my point, eh?
Yeah.
Because what I am saying is, if x greater than 1, because when you are evaluating this limit, you don't have this part, no? You are just taking this limit. So if x greater than 1, this limit is infinity. If x equals 1, this limit is 1. It is always 1. If x less than 1, it is 0. So you have 3 answers actually. Limit x tends to 1 minus, you have 3 answers, infinity, 1 and 0. So he has not been careful, I guess. Actually, I don't know whether you had a different question about this book. I mean, he is a real big shot in the world. All the people here are from India. Yeah, I was actually wondering why on earth it is the case. Because I was looking for mathematicians that I know. I don't know anybody here. Manindra Agrawal, I know the Agrawal name. V. Balaji, R.V. Bhatta, Bopat, E.S. Boka, Ramadas, Srinivas Ramanujan is famous like that. I was wondering why on earth he has. Anyway, so what he is pointing out here is we just cannot interchange limits. There must be reasons. If we are interchanging, we have to have the reasons before we do it. Then the next example is also something like that. What is he saying? Interchanging limits and integrals. Here. He has the integral for any real number y, we have minus infinity to plus infinity 1 over 1 plus x minus y square dx. I mean, you know, you guys are very good knowing A level. This is, you write arc tan over tan inverse. How do you write? Tan inverse. This is tan inverse x minus y. x goes from minus infinity to plus infinity. So x is minus infinity, then you get, if you plug infinity, arctan infinity is pi by 2, no? And minus infinity is minus pi by 2. So 5 by 2 minus 5 by 2 is 5. Taking limits as y tends to infinity, we should obtain, if you take y tends to infinity, inside you are taking the limit. If y tends to infinity, dx is equal to limit what? What did he do?
We interchange the limit function with the integral function.
Taking limits as y infinity, we should obtain minus infinity plus infinity, y tends to infinity dx. If you are taking the limit y tends to infinity, isn't that 0? No?
Yeah.
If you take limit as y tends to infinity, that limit will be 0.
In the bottom he has written, but for every x we have.
But for every, we have limit y tends to infinity is equal to 0. Right? No, what he has is showing inside if you do it 0, but after integrating if you do it, you get 5. That's what he is saying. No? So we seem to have concluded that 0 is equal to 5. What was the problem? Anyway, same thing. No? We cannot, all he is pointing here is that you just cannot do what you would like to do. Most of the time you cannot do it. That's what he is pointing out. Then interchanging limits and derivatives also. Same thing. He has an example here. X cubed divided by epsilon square plus x square. So he has got the derivative by, I guess, quotient rule. Quotient rule. What is the singular name for quotient rule? Anyway, he has some, and in particular, if you plug x equal to 0, answer is 0. And you would know how to get it. Taking limit as epsilon to 0, one might then expect that d by dx, this is equal to 0, because if you take epsilon, if the limit of the x cube over epsilon square plus x square, as epsilon goes to 0, you get d by dx x cube divided by 0 plus x square. However, then derivative of, if because the top answer is 0, you expect this to be also 0. However, x cube over x square is x, derivative of x is 1. Therefore, you cannot do it. That's what it says. Clear? Are you getting, or shall I explain?
No.
This is very clear. But actually, what happens is, most of the things, once when someone points out, we can see that it is wrong. Then our question is, when can we do it, and can we prove it? Sometimes certain things, proof of, even I told you proof of chain rule is a difficult one. It is difficult. So, again, interchanging derivatives. Second derivative, again he has this example, fxy. This is again the famous one. Xy cube over, if you look at Ruding's book, Apostle's book, you can see this example. Fxy, xy cube over square plus y square. The common maneuver in analysis is to interchange two partial derivatives. Here he is pointing out it cannot be done. I guess you can do it without a problem. here for this function, is you have learned how to get partial derivatives?
Not in A level, but we searched it out.
Now you can do it.
Okay.
The best way to do is let's say for instance, no, some easy example. Fx equals sin xy. Sin x squared, say y cube. So function of two variables. Now we want to find fx comma y. So we write this letter daba fxy divided by say daba x. That means partial derivative of fxy with respect to x. So if you have a problem here, only variable is x. So you can think when you are doing this thing, you can say this is x squared, some books. Y cube is a constant. Y cube is a constant. So if you want to differentiate this one with respect to x, you get cos x squared books. If you want, you can write a number even, it's a constant. Then times derivative of x squared box is 2x box. No big deal. No big deal. So here you get then cos x squared box is my y cube 2x y cube. So when you are differentiating with respect to x, other variables are treated as constants. Just get the derivative.
Multiple variables, there are no function. A function equivalent to partial derivative companies.
Could you say it again?
Function එක multiple variables තිරුණා විතර එතකොට අපි partial derivatives එක
Okay. Partial comes when there are more than one variable. You have to have more than one variable to use this symbol, otherwise it doesn't make any sense. Sometimes, however, sometimes you has not taken lesson. Sometimes you have to have the say definition. D by dx, dfx by dx, say at x equals 5 means the derivative is you have to evaluate f of 5 plus h minus f of 5 divided by h as limit h tends to 0. We will be doing them seriously later. But this is A level. Derivative of fx at x equals 5 is limit of f 5 plus h minus f5 divided by h as h tends to 0. Similarly now, say suppose you have fxy, some functions for assume xy divided by x squared plus y squared. If xy not equals to the origin, if xy is equal to the origin, let's say 6. This is a two variable function. Then if you want to talk about the derivative of this function with respect to x, with respect to x at say 0, x equals 0. partial derivative of fxy with respect to x at x equals 0. Now y is fixed. Y is fixed, y is, you can think y is like 10 or 15 or box or whatever, something like that. So here you have at the point 0, you have a, here you can substitute 0, 0, because then you get 0 divided by 0. So you have to do it separately here. No, 0 divided by 0 doesn't make any sense, no? That's why I wrote at the point 0 it is 6. No, you don't have to go that far. Say suppose you have fx over x. This graph is whether you write this way or not. This is fx equals 1 if x is not equal to 0. This is not defined at x equals 0. Not defined. If somebody asks you to draw the graph of x over x, nothing at the point 0, otherwise it is 1. Graph of this thing. At the point 0, it is not defined. So, in a thing like this, you have to do it separately. But if you get this kind of nice formula, you just apply. Certain times that I gave you a problem, let me not do it, you will do it someday. So for a thing like this, we have to apply separately. I mean, partial derivative of fxy with respect to x is, you write limit f x plus h comma y minus fxy divided by h as h tends to 0. That's the definition. Only y remains the same, but x is changing. We are learning them seriously later, but today I am just roughing the surface. Because he is going for examples in 2-3 variables like that. Anyway, what he is trying to make you curious, again he has an example in page 10. What is it? L'Hopital's rule. You have heard the L'Hopital's rule? So it is a very big one actually. Sometimes in USA for you, sometimes in your PhD qualifying exams, they ask you to do L'Hopital's rule. Because the thing is, you from A-level first day onwards, you use L'Hopital's rule. You don't know how to prove it. It's difficult to prove. It is difficult to prove. Nobody expects the proof of L'Hopital's rule in general. But that's why they ask in PhD qualifying exams, they ask proof of L'Hopital's rule. Because they get ready for difficult ones, not for L'Hopital's rule. Proof of L'Hopital's rule is very complicated. Yeah, very, very complicated. L'Hopital's rule, but we will be doing this thing in a very serious way. After, I guess, we have to do some of these chapters, finish. Alright, let's look at the L'Hopital's rule in general. This is how we write. Limit of fx by gs as x tends to x0 is limit of f dash x over g dash x as x tends to x0. That is how we write. Are you sleepy? But one can still get led to incorrect conclusions if one applies it incorrectly. this is also one that people do mistakes. You understand what I mean? For instance, applying to fx equals x, gs equals 1 plus x, and x0 equals 0. Fx is x, gx is 1 plus x, x tends to 0, x, you get 1. But this is the incorrect answer, since limit x tends to 0, x over 1 plus x, if you actually compute the limit, it is 0. X over 1 plus x tends to 0, no? If you apply the L'Hopital's rule incorrectly, derivative of fx equals x is 1, numerator is 1, derivative of 1 plus x is also 1. 1 over 1 is 1. So from L'Hopital's rule you get the limit is 1. When you calculate limit normally, you get 0. So that's something wrong, no? Of course, all that is going on here is that L'Hopital's rule is only applicable when both fx and gx go to 0 as x tends to x0. In order to apply L'Hopital's rule, both fx and gx must go to 0. In this case, it is not the case. So that's why you are getting a wrong answer. A condition which was violated in the above example. But even when fx and gx do go to 0, as x tends to x0, there is still a possibility for an incorrect conclusion. Even if they go to 0, still it can be, what we are doing can be wrong, but we will do it, these things very rigorously we will be covering. I clean the board by this thing, and I get this thing on my hand, kind of dark. Maybe we should find a different duster. That day we had some.
Yeah, that's because you are on the second floor.
Today third floor. Yeah, but my book is getting dirty. Yes, this one cannot clean. Today maybe I can clean because I had your patties and your roll. Two of the things can have kind of energy, but my shoulder gets hurt. He is pointing out here now x squared sin x to the minus 4 over x. Both numerator and denominator go to 0 as x tends to 0. Can you see? X squared times sin x to the minus 4 goes to 0, and x also goes to 0 as x tends to 0. So it seems pretty safe to apply the L'Hopital's rule. To obtain, you apply that limit x tends to 0, x squared sin x to the minus 4 over x, derivative of x is 1, derivative of x squared times sin x to the minus 4 is 2x sin x to the minus 4 minus 4x cube minus cube cos x to the minus 4. I mean, you apply the product rule to get the derivative, then you get limit of 2x times sin x to the minus 4 minus 4x to the minus 3 cos x to the minus 4 as x tends to 0. You can see limit of the first term is 0. Limit of, again, if you don't know, it's okay because I will be covering them absolutely well when the time comes. However, when x tends to 0, 2x times sin x to the minus 4, that limit is 0. But the second limit, 4x to the minus 3, when x tends to 0, does not have a limit. Now, for instance, 1 over x does not have a limit as x tends to 0, no, you know that, right? 1 over x limit, x tends to 0, 1 over x, there is nothing like that, because
The left hand right doesn't.
graph of 1 over x is something like this. No? If you are coming to 0 from the plus side, limit 1 over x, x tends to 0 plus, is plus infinity, and limit of 1 over x, x tends to 0 minus, is minus infinity. Thus, limit x tends to 0, 1 over x does not exist. It doesn't have a limit. At same way, this 4x to the minus 3, when x tends to 0, does not have a limit. So you cannot apply this thing. The first converges to 0 by the squeeze test. Squeeze test we haven't done. Since the function, we haven't done any analysis. Why should I say we haven't done? Nothing. So that is something unfair about the book. Regardless of how good he is, quite often we have to use things that we haven't studied. That's not good. Now, when I was writing these books, I was very careful what the students know. My examples were based on what they knew. Here, it's not the case. Anyway, since the function 2x times x to the minus 4 is bounded by 2 times mod x and below by minus 2 mod x, both of which go to 0, at 0. But the second limit is divergent because x to the minus 3 goes to infinity as x tends to 0. That's again, I don't like it. Can you see here? X to the minus 3 goes to infinity as x goes to 0. That's not true. X to the minus 3, again graph is like this. This is graph of 1 over x, no? 1 over x to the 3 is also like this. So that's not, are you getting my point? So what he says is not good because x to the minus 3 goes to infinity. I mean, if it goes to plus infinity from plus side, then minus infinity from minus side. Squares will develop. Squares now, 1 over x to the 2, 1 over x to the 4, they go to infinity. Yeah. So the limits anyway, somehow there is no limit. One might then conclude using L'Hopital's rule that this also diverges. However, we can clearly rewrite the limit x which goes to 0 and x is 0 by squeeze test again. This does not show that L'Hopital's rule is untrustworthy. Indeed, it is quite vigorous. See sections, he told the right word, quite vigorous. L'Hopital's rule is quite rigorous. That's why they ask this thing in PhD qualifying exams. Yeah, sometimes you can, now if you ask me to prove now, because I haven't done analysis for 5 years, I may not be able to do it now. Yeah, it's not obvious. Tell hospitals. I don't know why they say it, and I also say like, because I have heard others are saying that's in my case also, when I was in the Colombian University, when I saw it, I said L hospitals. But there is no ST even here. Again, when you are writing, O, you put that on the top of O. Again, next example is interesting to that. Just do it. Next day, can you find a different one? Otherwise, my book will be very great.
So try folding the cloth the other side.
Eh?
Try folding the cloth the other side.
Ah, that's a good one. Yeah. Anyway, already book is dirty. You know how to do area of a circle of radius r is pi r square, right? And there is one problem with that area of the ellipse. X squared over a squared plus y squared over b squared equals 1 is phi a b. There is a problem. Tell a question or something like that. This came to my mind because of the next example. Limits and lengths. Sometimes what we think is not true again here. When you learn about integration and how it relates to the area under a curve, you were probably presented with some picture in which the area under the curve was approximated by bunch of rectangles. That's how you calculate the area of a circle of radius r is pi r square, as well as what? Area of this ellipse x squared over a squared plus y squared over b squared equals 1 is phi a b. You always approximate by rectangles whose areas was given by a Riemann sum, and then one somehow took limits to replace that Riemann sum with an integral, which then presumably, and you see, you haven't done these things. He says you have done it. That's not true. There, you will do someday, but in A level you don't do this now. In A level actually you don't. A level students don't know the definition of integral.
මේ අපේ වයසට ඒ කියන්නේ කැම්ප් එක කොලෙජ් එකට යනකොට මෙයා කරන්නේ. ඒතකොට කොලෙජ් එකට යන්න කලින් රීමාන්ස්
Have they are undergraduate calculus courses cover Riemann sums etc. not in a rigorous way, but it was introduced. In Sri Lanka, it is not the case. In Sri Lankan A level is like a rat race, no? I mean, there are some bunch of papers, you practice them, go and I guess everybody almost everybody who sits A level, they know how to do each and every problem, but you have to do it so fast. It's like a race. So this thing has no place in A level. That's a very big disadvantage. Perhaps a little later you learn how to compute the length of a curve by similar method. Approximate the curve by a bunch of line segments. Compute the length of all the line segments. Then take limits again to see what you get. What he is saying is when you want to find square areas, you divide this thing into many rectangles. Then you take the area of this one, 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 this one. You add all of them. Sum of them. areas of rectangles. And again, then you find the limit of this thing as maybe this length goes to 0. So that is called the the area, but we will do it in a very nice way later, not today. Let's read his example. It's a good example, by the way. However, it should come as no surprise by now that this approach also can lead to nonsense if used incorrectly. This one is a good example. Consider a right angle triangle with vertices 0, 0, 1, 0, 0, 1. This rectangle, this one is 1, 0, this one is 0, 0, 0, 1, sorry. And here is 0, 0. And we want to find the length of this segment. What he says is, and suppose we wanted to compute the length of the hypotenuse of this triangle. Pythagorean theorem tells us that this hypotenuse has length square root of 2. That we know very well. But suppose for some reason that we did not know about Pythagorean theorem. I guess everybody knows it. And wanted to compute the length using calculus methods. See what I am saying? Suppose you forgot about Pythagorean theorem and you want to calculate the length of hypotenuse by this limiting style calculus. Well, one way to do so is to approximate the hypotenuse by horizontal and vertical edges. Pick a large number n and approximate the hypotenuse by a staircase consisting of n horizontal edges of equal length alternating with n vertical edges of equal length. What he is saying is staircase. No? You take capital N and n, you divide n, then you get it's too low. This kind of scale. Then you get this lens. At the lens, if height is 1 over n, no? This is 1 over n, this is 1 over n, this is 1 over n, 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 1 over n. You get 1 over n. So we want to find the length, we don't know how to find it. Now we are approximating the length of the hypotenuse by this staircase. So what does he say here? Clearly these edges will have length 1 over n. Everyone has, for either direction, has 1 over n. So this side you have 1 over n, n 1 over n's. This side you have n 1 over n's. Horizontally, n 1 over n's. Vertically, n 1 over n's. So 2n over n. No? Length is 2n over n, which is equal to 2. If one takes limits as n goes to infinity, the staircase clearly approaches the hypotenuse. When you limit, when you f tends to infinity, staircase goes to actually the hypotenuse. No? So if one takes the limit as n goes to infinity, the staircase clearly clearly approaches the hypotenuse, and so in the limit we should get the length of the hypotenuse. However, as n goes to infinity, the limit of 2n over n is 2, not the square root of 2. So we have an incorrect value for the length of the hypotenuse. How did this happen? So he is asking the question, how did this happen? So we have to answer something. What he said. Because analysis student might think, if he does not know the Pythagorean theorem, this is the way to do it. You approximate this thing by a staircase of height and the both are in same length and height 1 over n. You have capital N 1 over n horizontally, capital N 1 over n vertically. Then when you add, somehow you get 2 for any n to the contrary length of the hypotenuse is square root of 2. So there is a problem. Where is the problem? Is we have to answer. The analysis you learn in this text will help you resolve these questions and will let you know when these rules and others are justified and when they are illegal, thus separating the useful applications of these rules from the nonsenses. Thus they can prevent you from making mistakes and help you place these rules in a wider concept. Moreover, as you learn analysis, you will develop an analytical way of thinking, which will help you whenever you come into contact with any new rules of mathematics. So, when dealing with situations which are not quite covered by the standard rules, for instance, what if your functions are complex valued instead of real value? What if you are working on the sphere instead of the plane? That is in complex value. Again, you don't understand that. What if your functions are not continuous, but are instead things like square waves and delta functions? Delta function you don't know. What if your functions, delta coefficient you know? What if your functions, your limits of integration or limits of summation are occasionally infinite? You will develop a sense of binary rule in mathematics. Example, the chain rule works, how to adapt it to new situations and what its limitations, if any, are. This will allow you to apply the mathematics you have already learned more confident and correct. So, we just went through some examples in which many do wrong things, apply incorrectly. So, that his topic was, why do we do analysis? No. So, if you don't do analysis and apply what you know, in English there is a saying, one who generalize, generally lies. You cannot generalize what you know. Very often, for instance, I write 100 plus 10i. Get the number 3 plus 2i. Which number is bigger out of these two numbers? Which number is bigger, Buddha? Out of these two numbers? 100 plus 10i, 3 plus 2i. Which one is bigger? Buddha?
Neither as they are complex numbers.
Eh?
They are complex numbers. We don't have the traditional big layer.
Traditional comparison?
Yeah.
So, you cannot say 100 plus 10i is bigger than 3 plus 2i. Is that what you are saying? Yes, go. Buddha, right?
I think from the origin, when
Yeah.
you draw a line to the
100
plus
plus
10i and 3 plus 2i, they don't coincide on each other. No? There are
Yeah.
two different lines. No?
Yeah.
Therefore, you can't compare the length of it. Because normally when you compare the real numbers, they are on the same line. But if you take
Buddha, what you are saying is 100 plus 10i is somewhere here. This is 100. This is 10. So this is 100 plus 10i. 3 plus 2i, 3 is somewhere here. 2 is even somewhere here. So this is very short. You are saying you cannot compare, right? Bottom line is complex numbers cannot be compared. That I don't think we are doing real analysis, no complex is not done here. the reason I wrote this thing was, usually one tend to say 100 plus 10i is greater than 3 plus 2i because they want to generalize what they know. That's why I told you, one who generally lies. You cannot generalize what you know. It is a little small theorem in complex analysis that the book, I have written an excellent book about complex numbers to Open University. In that book, University, I show that complex numbers cannot be compared. So I guess for today, that's enough. I guess we just want to break the ice about, I guess, in your case, for instance, you are in Sri Lanka, Sri Lankan A level, who else in USA, college undergraduates, what they think cannot be generalized. Maxwell, there is no place that you can generalize. You may think of generalizing things, but then you have to prove it. You have to prove it. Just cannot say, because one of the tuition masters, don't ask me who came to my home some time ago, I asked him, he has written actually, don't ask any questions because I don't want to say about their names. He is saying this complex number is island rank 3, student also came to my home. Both of them were saying this one is bigger than this one, not these two numbers, but some big numbers here, very small numbers here. They did not know. Then I told you, like rats on fire. You are generalizing things that cannot be done in mathematics. I guess you can't. That's enough for today. But next day we have to be, today, after tea, we have been just talking about what one does incorrectly in mathematics. Next day it is not the case. We have to be very serious about his introduction to piano axioms and starting at the beginning, the natural numbers. So he has a different approach. We have to be careful, but I expect you to read the book. I don't know how I deal with you because it is different approach. But anyway, today's Friday, I have 3-4 days to decide how to do it. And did you learn anything after coming today?
Yes.
That's good, that's good. You replied also for some questions.
Sorry.
Yeah.